So welcome everyone to today's Retrofit Talk. I'm Laura Broderick. I'm the Commercial Partnerships Manager at the Building Centre, and I'll be hosting today's session, Low Energy House, a retrofit of an Edwardian terrace. Bit of a tongue twister for me there to start. But before we hear today's presentation, I want to tell you a little bit about the online talk series, part of Retrofit 23 at the Building Centre, designed to connect professionals and discuss residential retrofit. We're here to showcase the latest research and projects from architectural practice, offering valuable case studies and solutions for retrofitting homes. Our guest speakers will present their projects. This will be followed by a Q&A session with you, our webinar audience. So this is our fifth talk, and if you missed the past sessions, including last week's with Marion Bailey of Studio PDP, you can catch up with the recordings via our website or our YouTube channel. But back to today. Ben Ridley is Director of Architecture for London, a practice he founded in 2009. They're architects who create healthy buildings with natural, breathable materials and are working to the highest sustainability and comfort standards, including Passive House and Enefit. Indeed, Director and Architect Ben Ridley is an accredited Passive House designer himself. The practice also offers a unique healthy homes design service, and they seek to create homes that benefit both from improved air quality and thermal comfort of the passive house construction, whilst also using volatile organic compounds and natural materials wherever possible to create healthy indoor environments. But today, Ben will specifically talk about his own home, the Low Energy House, which recently won the NLA's Don't Move, Improve award. So well done to Ben and the practice for that. We'll get a deep dive into how his Edwardian terrace in Muswell Hill was extended and refurbished to create a comfortable low energy home. The original structure of the house was revealed, its beauty celebrated. And this project aimed to be an exemplar for sustainable refurbishment of a typical terrace in London within a constrained budget. So I know we'll all want to hear about the beauty and the construction, but also some of the budget constraints. I'm sure you'll have lots of questions. Please use the chat function in the webinar to leave those, and I'll address them after Ben's presentation, which will last about 20 minutes. I kindly request that you focus your questions and aim to avoid making statements. This will make it much easier for me to moderate and for Ben to answer. So now over to Ben to talk to us about the Low Energy House. Thank you, Ben.
Thanks, Laura. Hi, everyone. Yeah, I'm Ben, and I'll talk to you about my own house in Muswell Hill and the low energy retrofit that we did there. So just share a screen with you. So the title is Age of Extinction, and what I wanted to also talk a bit about was the climate emergency, and within that the species extinction, which we don't really talk about maybe as much as we should do. And that is important because it's already happening at pace. So I've included some quotes about that here, just to remind us about why we do these low energy retrofit projects. So the first quote: "It's impossible to exaggerate the awesome nature of the challenge we face. Global warming is already a prime factor in destroying species at a rate not seen for 65 million years." And obviously, the UK signed up to net zero by 2050, and the built environment is a really important part of that because it's responsible for about a quarter of our total greenhouse gas emissions. And the thing that's crucial to bear in mind is that homes we refurbish now aren't going to get refurbished again before 2050. So every project that we work on is really crucial. And for us, it's thinking about, although this is a single test case project, how we think about this at scale. So how we do this to all of our homes in London and all of our homes in the country. And we think that it's about a balance of sustainability, budget and aesthetics. And that's what we need to scale. So in terms of location, the house is in Edwardian suburbia, just north of Muswell Hill in North London. It's on the corner there of quite a busy road, Colney Hatch Lane and Hallowick Road. The project is a loft conversion rear extension and a retrofit. And we also removed quite a lot of the internal walls at ground floor, just to create a more modern open plan living space and allow the natural light to be shared around that space a bit better. And as it's my own house, it's a really good opportunity for a test case retrofit for the practice. And it's of an ordinary London terrace house on a relatively small budget of about 250k. So these are a couple of images of the house as I bought it. Very typical uninsulated brickwork, Edwardian construction. Few issues like someone had cement-based rendered the front of the house at ground floor, causing lots of damp problems inside, which we can go into a bit later. Still quite a lot of original single glazed windows. Yeah, and then generally internally, superficially in quite poor condition, as you can see from these photos. But more importantly, some real problems with the house. So on the right photo there, you can see a classic Edwardian ventilation detail of just having a big hole in the wall and the moisture ingress and condensation problems that's resulted in. You can see in the discoloration and mold growth there in the wallpaper. And on the left, some of the rooms face directly north, so you have this problem with one window rooms with really low levels of natural light. So that was something we wanted to address as well. This shows one of the original single glazed windows, condensation problems causing mold growth there along the bottom, along the sill. And also just to mention, I have a bit of a mold allergy, and I moved flat about 5 times within a year because of my mold allergy issues. So this was something that was really important for me to get right in the house and make sure everything was solved. And then the photo on the right, that's the original rear reception room at ground floor. So it shows there's an original single glazed window, but beyond that, in the side return, someone had built a very small kitchen addition, and that effectively blocked off all natural light to that room. So it was a very dark and uncomfortable room. And then a bit of opening up work. And this is the front bay. The 2 left images are ground floor and the 2 right images show the first floor front bay. And it really shows the historic damp proofing work damage that caused. So essentially a cement-based damp proofing plaster was added up to 1 meter above the finished floor level in both the ground floor and the first floor. And what it did was just trap moisture because it's non-breathable. It trapped lots of moisture within the wall, pushed that moisture upwards, and then it deteriorated the lime plaster line at that 1 meter level. And all that lime plaster was blown and very, very damp. And you can see the bottom left image there. We just peeled back a bit of the cement-based plaster, and the face of the brickwork came off with it, where everything was so damp. And on the right, you're seeing all of the lovely variety of species of mold growth and damage there. So it's almost certainly too late to save some of the world's great living wonders, such as coral reefs and monarch butterflies. With every increment of global heating, we'll have to accept still greater losses. And moving on to the embodied energy, the proposed engineer's drawings. So about half of a building's embodied energy is typically in its structure. So the obvious thing is to try and reduce the amount of steel and the amount of concrete being used in the project. So at ground floor, we reduced steels by trying to retain masonry nib walls. So where we have this wall here, rather than open the whole wall out and create a completely open plan space, what that does is give us the lateral stability, so we don't have to have a big steel box frame. We can just have a single steel supporting the load from above. And again here, this is another nib wall retained for lateral stability, so we just need a single steel above that. On the rear extension, we didn't pour a continuous concrete slab. Instead, we just had stripped foundations and then carried on the suspended timber floor into the new extension. So again, saving a lot of concrete being pumped into the ground. And the loft conversion here, you can see on the second floor plan, we try to avoid using any steel at all. So it's all done with timber beams, so doubled up timber beams and posts, and then just a single flitch with a small amount of steel in it was all that was needed. And then embodied energy in terms of finishes, this was an early visual. So we were trying to minimize use of concrete-based and plastic-based building products, and instead using things like lime plaster, natural stone tiles rather than ceramics and concrete, and timber finishes throughout. And then energy in use. So this obviously is made up of heating and cooling, ventilation, power requirements, lighting, appliances, and hot water. And one of the biggest things that we can change is the energy needed to heat a building. And we work to passive house principles. So they are insulation, airtightness, and MVHR. And we were aiming for passive house fabric U values of 0.15 everywhere, which we've achieved, except for at the front facade. And yes, this drawing shows some of the ground floor wall types. So at the front there, because we wanted to keep the Edwardian character, we insulated internally. So that's wood fibre there shown around the bay. But everywhere else we insulated externally because it performs much better. First floor wall types, you can see lime plaster everywhere, and again, wood fibre internally around the front facade and the bay. And then the loft conversion, one thing to note here, the adjoining neighbour's loft hadn't been converted, so we then obviously needed to insulate internally at this floor along the party wall, so that was done in wood fibre too. And then the other thing you can see here is the MVHR unit located in the loft, and to the new stair we added a curve in plan, and what that did is it gave us a little void here that allows the MVHR ductwork to run down through the stair into the lower floors of the house. And a detail through one of the new triple glazed Velfac energy windows in the side of the house. So that's the condition where we have the external insulation and the window is pushed out so that it is within that insulation layer to try and avoid any cold bridge between the window and the insulation. And section showing the MVHR runs and diagram. There's disastrous consequences for wildlife if human-caused emissions push global temperatures up to 4.4 degrees C, which is currently what we're heading for. Extreme heat could endanger 40% of land animals by 2100, with extinctions and collapse of ecosystems becoming commonplace. Some photos during the construction process. That's the wood fibre going on internally at the bay. On the right there, you can see that's the stair, but also just behind that is one of the new steels with the nib wall retained so that we don't have to have a steel box frame. And on the outside, you can see there the external insulation going on at the side and the rear. And that's the rear extension with the SIP panels now in place and the finished wood fibre insulation to the front bay. And you can see there we've taken down the ceilings, obviously, to be able to insulate between the joists there, so we don't have any thermal bridges. And then in terms of air tightness, this diagram from Intello in the top left there is a pretty good example of what we did everywhere in the house. So where we have masonry, here we used a thick coat of lime plaster, and that gives us our air tightness layer that's taped up at junctions like windows. Intello Plus membrane used for timber construction, so where we have the ground floor, the rear extension, and also the entire loft conversion roof. And then the diagram here shows that the difference between typically what the building regulations allow for a house, which is for holes throughout the entire building to add up to the size of 2 cash points. So that's quite a lot of air leakage. Whereas if you're aiming for a passive house, which we try to do in our projects, you need to get that right down to credit card size, all of those holes added up. So it shows you the difference there and how hard that is to achieve. And yeah, the diagram also shows all the various tapes being used and grommets where you have services puncturing through the airtight layer. And a photo from the construction showing the loft. This shows the doubled up timber beams and a timber post there. And the other benefit of not having a steel within the thermal layer in a loft conversion also is that it avoids that typical cold bridge of the steel. Similarly, we also avoided any ceiling mounted downlights to avoid the small cold bridges there in insulation layer. And this is a south-facing Velux, so it's triple glazed, but also we have our external integrated solar shading there to reduce the amount of solar gain you're getting. And testing, so the image on the left shows the air tightness test in progress. So sealing up the front door with a blower fan, pressurizing and depressurizing the house. As the test is being done, you can go around with a smoke gun and you can see where all of the problem areas are. And some of those images on the right, the problem areas highlighted. So one of them on the top right there is the junction between the new SIP extension and the original part of the house. And the tester described it as blowing a gale through a hole there. So there's a real issue that needed sorting there. And a couple of smaller problems where the airtight tape obviously hadn't been installed correctly at the bottom junction of windows on the ground floor. The first airtight test was 5.2 air changes an hour, and the second airtight test was expected at 3.5 once those issues have been solved. Global warming is projected to commit over 1/3 of the Earth's animal and plant species to extinction by 2050 if current greenhouse gas emission trajectories continue. A catastrophic loss that would irreversibly reduce biodiversity and alter ecosystems across the globe. In terms of cost, the total contract sum was about 250k. There were a few client applied items on top of that, but overall the total spent on low energy items was about 34,000, and that was mostly made up of 10,000 MVHR and 20,000 on insulation and air tightness. The uplift for triple glazing over double was fairly small, about £4,000, and probably the low embodied energy items, so things like using timber instead of steel and using stone instead of concrete, had no net cost, so it's a no-brainer. And just to note, really, form factor is obviously one of the things that you can't influence as much when you're doing a retrofit because the building is already there. But typically in London, our terrace houses have a reasonably good form factor because they are compact in form and they share a lot of heated walls with neighbouring buildings. So yeah, we're starting off from a reasonably good standard. World biodiversity has declined alarmingly in the past 50 years. Earth's wildlife populations have already plunged by an average of 69%. So just some before and after photos. One that you can see here, the insulation, external insulation layer, you can just see on the right-hand side of the house there. That was actually set back slightly on the outside to avoid a sort of bulky detail there, but to avoid the thermal bridge, we then return the internal insulation round into the chimney breast recess to try and cover that as best as possible. And then before and after of the stair. So yeah, showing space is much more open plan now, and a lot more natural light bouncing around the house. This wall at the end is a good example of that original lateral stability wall retained. And obviously there, because it's not a external wall, it meant we could have a much thinner layer of lime plaster, so it reveals the nice texture of the original bricks behind. And completion photos showing the front bay and refurbished front door with new stained glass added. So here, actually, the new windows were double glazed, but we added a secondary glazed layer internally. So it's effectively a triple glazed system, and actually is better for acoustics. So it reduces noise even more than a triple glazed window would do. And it's a magnetic secondary glazed system. So actually it performs really well for airtightness too. And I'm very happy to report there hasn't been any damp and mold since after the build. So that's great. Astrid the cat enjoying his new home. That's the bedroom on the right-hand side. And some details of the lime plaster and one of the new bedrooms at first floor. Stone timber finishes throughout, including in the bathroom. First floor bedroom. And that's a view outside from the rear. That's a new triple glazed oak framed garden door and window. And on the right is the loft conversion of the triple glazed Velfac window. And the cupboard you can see on the left is the MVHR cupboard. And a view of the kitchen and looking out towards the garden. So as well as the sustainability benefits, obviously there's the benefits of having a comfortable and healthy home. So occupant comfort is that it's a warm, draft-free house with underfloor heating. So you have the heat where you want it, which is at your feet rather than at your head. Much lower energy bills. So we calculated about an 80% saving on space heating. Improved indoor air quality. So the MVHR unit has a HEPA filter in, so that removes NOx and diesel particulates, but also pollen. So if you suffer from hay fever, like I do, that can really improve symptoms. Stable indoor temperatures. That means that there's much less risk of cold condensation and mold growth, and also avoiding cold bridges too. And also it's quieter, so the acoustic comfort, because we live near a busy road, that insulation and air and triple glazing really helps. And also the same if you live near flight paths, which many people do in London. And then the low energy demand expands the potential for on-site renewables, which we're hoping to look at as a part of phase 2. And obviously this is quite a deep retrofit project, but there's lots of things that we can do very simply and quickly to all of our houses in London now. So things like draft proofing, secondary glazing, and on the left, that image shows a magnetic letterbox flap. So that is a really cheap £15 solution that gets rid of the really large draft thermal bridge that you get in every front door in London. And finally, that's Astrid enjoying the new underfloor heating. But if you can get to Passive House standard, the interesting factors, as well as obviously the free thermal gains from human occupants, solar gain, and things like appliances, you can get up to a comfortable temperature of 21 degrees without any other internal heat sources. So you don't need radiators or underfloor heating, as long as you have 17.4 cats. Thank you.
Thank you so much, Ben. I enjoyed that presentation lots, and I'm sure everyone else did as well. So We've got about 15 minutes for questions, and I can see quite a few have started to come into the chat function. We'll do our best to get through as many as we can in the 15 minutes. If you do have any further questions, please pop them in now so that we can kind of get a sense of what's being asked of Ben. So Ben, I'm just going to go through them one by one. So the first question from Hassan was about issues with thermal bridging at the point of change from internal to external insulation. I think you started to answer that towards the end of your presentation around the chimney breast, but is there anything else you want to add to that one?
Yeah, so obviously it's never perfect where you have that junction, but normally the recommended solution is to try and have an overlap of about 1 meter between internal and external. And what it means then is that the heat, if it is going through those two layers, it still has to travel through 1 meter of brickwork. So there's obviously there's some sort of resistance through that.
Great, thank you, Ben. Next question from Mark. Did you get any thermal imaging done after your retrofit was finished?
I haven't actually yet. I still need to, I still need to do that. We have got a camera in the office, so I need to do that.
Yeah, you've got the kit. Okay, great. A longer question from Tom. With the focus on reducing embodied carbon and using wood fibre insulation, was there any consideration of using PIR insulation in the loft or SIPs for the extension? And Ben, as you answer, could you help with acronyms for those who don't know them?
Sure, yeah. So we did use wood fibre internally, and that's where you really have to use it because it avoids the risk of condensation. But externally we used phenolic Kingspan insulation, and that is a plastic based product. Originally we were looking at using wood fibre, but to achieve that passive house U value of 0.15, it would have meant a much thicker layer, so probably 450 mil, I think it was. And the issue you start getting into there is budget costs, but also the kind of bulk in addition that adds to the outside of the house. So yeah, there's obviously a trade-off there in cost and performance, but it was felt that was the way to go. And then in terms of the SIPs for the rear extension, again, it is plastic-based product, but at that 172 version, you're hitting the passive house U values for a very thin wall build-up, which is crucial in those sorts of rear London extensions where every square meter is crucial.
Excellent, thank you. Question about the floor finish. So what was the floor finish on the first floor?
So the first floor is timber floor finishes throughout, but you probably saw we took out all the ceilings at ground floor. So that meant on top of the original floorboards, there's a 15 mil layer of acoustic sound mat. And then there's underfloor heating. So there's an extra insulating board on top of that. And then finally, it's the timber floor finish on top.
Great. Cheers, Ben. And from Matteo, I see you removed the ceiling. Did you try to minimize the sound transmission between first and ground floor?
Yeah, exactly. So that was it. And I think it probably performs about as well as it used to with a plaster ceiling in. So it's definitely not a perfect solution, but it's good enough for a single family house, I think.
Great. And then question from Nick around budget, looking for, well, thanking you for your presentation initially, but looking for a bit more clarity about the cost of 250K. I think you said that was construction cost, but what was included? VAT, fees, testing, client supplied items? Sorry, there's a bit of typing error on that. I can't quite see. So yeah, just if you could expand a bit more on the budget breakdown.
Yeah, so it's a contract sum, so it was not including VAT, and there were extra client supplied items of about 50K on top of that. Everything is included except for consultants' fees, so it doesn't include architects' fees or airtightness testing or engineers' fees.
Great. Thank you, and I hope that's answered your question, whoever asked. Bit of fan for the cat, for Astrid. She's getting some love in the chat function, so just give a shout out to Astrid.
I'll be very pleased.
She will be pleased, of course. And back to the exposed ceilings. I think you answered some of this around the acoustic, but someone else asking around acoustic and heat. So maybe you could say a bit more on the heat with that. So how did you deal with the heat through those exposed ceilings?
Yeah, so the heat, really, you only need to think about as the external envelope of the building. So everything within the outside walls, roof and ground floor is just treated as one space. So you're not really worried about heat transmission between ground floor and first floor. It should, in theory, be really stable, constant temperatures everywhere in the house.
Okay. Amazing. And then a few questions around fire compliancy. So how would you describe it? And then like the rating for the exposed timbers for the joists. Yeah.
So yeah, the timbers are coated with EnviroGraph. It's a clear coating, so that is intumescent, so that deals with the fire separation between floors.
Great, amazing. Yeah, and then lots of compliments, beautiful job. Did you assess the embodied carbon in fixtures and fittings?
No, I mean, I can't say I went into too much detail on embodied carbon other than trying to use those simple rules of thumb and reduce the amount of steel and concrete. I mean, one thing I would, well, it's kind of obvious, but buying good quality fixtures and fittings that will hopefully last for 30, 40, 50 years. And the same with furniture. It's something that we've tried to do. And yeah, hopefully there's a sort of investment in embodied carbon that will pay back over time with those things.
Yeah, as you said at the beginning, you don't want to be retrofitting again before 2050, etc. and things. Yeah. Okay, so longevity of product within the home. Another thing you talked about at the beginning, Ben, was hopefully some of the lessons could be learned at scale. You talk about the terraced house typology, but someone's asking, Namrata's asking, do you see any challenges to apply that to social housing stock? So obviously, like the scale of that challenge.
Yeah, I think there's definitely challenges there, especially with tenants, relocating tenants. Yeah, doing these things at scale, but budgets, obviously there's challenges. But I think there's, obviously really potentially great rewards there of ending fuel poverty. Perhaps they're the people that need these things the most, and will see the biggest improvements in quality and financial benefits that go with that.
Thank you. Okay, we've got quite a few questions left. How are we doing for time? I think it'd be all right to take maybe another sort of 3 or 4. Is that okay with you, Ben? Yeah. Amazing. So some more questions around the sound installation. I think you've got to that. The heat recovery system, a question around that. So this is from an anonymous attendee. A lot of people are talking about insulating houses more, but without installing a heat recovery system, wouldn't this have the potential to make condensation mold a bigger issue? So obviously you did explain more about your thoughts on that. Sorry, Ben. Yeah,
so it really relates to the air tightness. So once you're aiming for an airtight house, whereas previously the house is naturally ventilated, so you're allowing moisture to escape through all the gaps in the construction. When you have an airtight house, you then need to deal with ventilation another way. And there isn't too much of a risk, I think, until you start getting down to levels for about 5 or 6 air changes an hour. And at that level, usually it's recommended to start installing an MVHR. And typically a Victorian house like this might have about 15 plus air changes an hour. So yeah, it shows you that you do have to do quite a lot of work already to the air tightness to be actually having an MVHR and having it as a worthwhile investment.
Okay, great. And then a few more questions around budget. Like one, how would the budget of a typical sort of renovation project compare to a passive house retrofit? And then like cost savings that you kind of used was a second question from a different attendee, but maybe just you could take those both together.
Yeah, so I think there's varying costs depending really on what target you're aiming for. So we didn't hit the Enefit target, and a lot of that was to do with issues around airtightness and trying to retain sash windows and keep the original front door. But if you wanted to go all the way to Enefit or even Passive House, there would be extra costs. So I probably spent about 10% extra on low energy things. But if you're maybe thinking about 15%, maybe 20% extra, you could be heading to those Enefit levels.
Amazing. A few of the questions I think you've answered in other earlier questions around the suspended timber floors. A lot of interest in that. Fire compartmentation, how does that work at ground floor level? Because obviously you've made it very open, and yeah, you say a bit more on that.
So you'd need a separation between the ground floor living areas and the stair. That's the main thing you'd need. We should have had a fire curtain installed, but the budget didn't allow for that. So currently we have a no fires policy in the house.
Have you told Astrid? Yeah. Okay, I'll do two more questions, both with acronyms, one that I know, one that I don't. Okay, so we'll go with the one I don't know. What's your predicted heating demand, and was this project measured using PHPP?
Yeah.
Ben, say more.
Yeah, so PHPP is the Passive House planning package. Okay. So we did a rough initial study, but it wasn't done in too much depth. Yeah, so heat demand, I have got some bills, but I still need to finish the all the calculation. But yeah, it's slightly TBC, but we estimated about 80% saving.
Oh, great. Yeah. Amazing. So final question, just because we are running out of time and need to wrap up. So from Tom, compliments, great project. Do you have a comparison within the EPC ratings pre and post works? Yeah.
Oh, I don't actually. Yeah, I could commission an EPC now to, what was it before? I think it was pretty bad before, maybe a
F. Yeah.
Maybe an F, yeah, probably.
Yeah. Okay, great. Well, thank you so much, Ben, and thank you everyone for asking questions. I know we didn't address all of them, but just in terms of time. So Ben, just before I wrap up, how would people keep in touch with you as a practice? Keep in touch to find out more.
Yeah, very happy. If you want to send emails through or visit us at architectureforlondon.com, and all of our details are on there.
Excellent. And thank you so much, Ben, for taking the time to contribute to today's Retrofit Talks. We have recorded the event, so it will be available online shortly on the Building Centre's website and on the YouTube channel. So if you've enjoyed today and want to listen back or tell people, your colleagues and friends who maybe missed today, we do have another online talk next Tuesday, and that's with Lizzie Wester-McCutt from ECD Architects, and she's talking about a social housing project, and the talk is entitled "It Takes a Community." So do book on that. Again, it's free next Tuesday lunchtime, the 4th of July. We also have some in-person events happening, one indeed tomorrow Wednesday evening, the 28th of June, and we're going to be looking at the retrofit of estates, and we have 3 fantastic presentations of various estates across London for that. So if you are based in London and can come along, that starts at 6 o'clock, and you can find the Eventbrite booking link on our website as well. So yeah, do just keep in touch with the Building Centre and our retrofit programme. It's been great to have Ben speak today about Low Energy House, and yeah, we look forward to seeing you at future events. So thank you very much, Ben, and thank you everyone for attending.